Unit 1, Part 2. Number 7, weight is a measure of the gravitational pull on an object. Since the Earth is massive compared to the objects on Earth, the weight of an object on Earth results from Earth's gravitational pull. So let's take a look at this for a minute. Let's say this is the Earth and this is the Moon. So this is the Earth and this is the Moon. If something weighs 100 pounds on the Earth, it'll weigh between 16 and 17 pounds, so about 16.67 pounds on the Moon. And why is that? The Earth's gravitational pull is about six times stronger than on the Moon. So if you have an object, it would have the same mass on the Earth and the Moon, but its weight would be different because of the gravitational pull being less on the Earth, greater on the Earth and less on the Moon. So number 8, mass is a measure of the quantity of matter. And number 9, the law of conservation of matter, and that states that matter cannot be either destroyed or created or destroyed in ordinary means in ordinary chemical or physical processes. This is a fundamental to chemistry and our understanding of chemistry. So what does that mean? In chemical reactions, we're going to find out that whatever matter goes into a chemical reaction, the same amount of matter comes out of the chemical reaction. Number 10, energy is defined as the ability to cause change or the ability to do work. Chemistry deals with energy stored in matter and with either the effects of energy has on matter or the production of different forms of energy, such as thermal energy, radiant energy, or electrical energy from matter. So let's give an example. Let's say that you burn some wood. When you burn wood, what you're doing is you're converting, or you're actually breaking down chemical bonds, and there's energy stored in those chemical bonds. The energy stored in the chemical bonds is potential energy. And then when we burn it, we're actually removing that chemical energy and converting it to light and heat, for instance. Energy can be classified as either kinetic or potential. Potential energy is described as the energy of an object in motion, such as a moving car or moving water down a river. Actually, the larger, the more massive an object is, if they're both going at the same speed, the more kinetic energy it will have. So if I have a car and a bird both flying and both moving in the same speed, the car would have much more kinetic energy than the bird because the car is much more massive. Potential energy, on the other hand, is described as the energy an object has because of its position or because of its composition. A rock located at the top of a hill has more potential energy than when it's located at the bottom of the hill. So let's take a look at that for a minute. Let's say that this is a hill. I have a rock, and the rock moves down the hill. Right? The rock had more energy, more potential energy up here. I'm going to put PE. So the PE, the potential energy, is greater here than it is down here. So there's more and there's less here. And that's because of position. But also, chemical energy or chemical bonds can store energy, and that's described as being potential energy. It's locked in those bonds, and only when you break the bonds can you actually remove the energy. Number 13, law of conservation of energy states that energy can be converted from one form to another, but it cannot be destroyed or created in ordinary chemical or physical change. So we can change energy from one form to another. An example would be if you look at electricity. Electricity, when it runs through a wire, can release heat. So the electricity or electrical energy is being converted into heat energy. So that'd be an example. Now, states of matter. There's three common states of matter. There's other states of matter, but these are the three states that we would most likely be exposed to in this chemistry class. So solid, liquid, and gas. And actually, I'm gonna add another video, and it will actually describe the three common states of matter, so I can go more detail. So look for another video, and it's specifically going over the states of matter. But matter can change from one state of matter to another depending on the amount of heat energy, kinetic energy, that it possesses. So if you look at the solid, liquid, and gas, gas has the most kinetic energy, and a solid has the least amount of kinetic energy. And when atoms are heated, you add heat energy to it. The more heat energy you add to it, the more they actually vibrate and move around. So a gas has a lot of energy, and the molecules are moving really fast. Or if you look at solids, they have the least amount of energy of the three states of matter. And they're not moving, they might be vibrating, but they're not moving from one place to another. Properties of matter. Properties are defined as characteristics which allow us to distinguish one kind of matter from another kind of matter. So what does that mean? So if I look at gold and copper, gold would have a gold color to it, but also its density would be greater than copper. And copper has kind of a coppery color. The color of copper is different than the color of gold, and the color helps you identify those substances. And physical properties are properties that can be observed without altering the identity of the chemical. Examples of physical properties include color, size, and temperature. So if I want to observe the color of something, I don't need to destroy it and actually be able to see it. Physical change, any change in the properties of matter that does not result in the change in identity. So if I convert let's say gold, I get it in a solid form, I can melt it, and I change it so from a solid to a liquid, it's still gold. It doesn't change from one identity to another. Changes of state. So you can change between a gas, liquid, and solids. And two common changes of the states of matter include freezing and boiling. Freezing is going from a liquid to a solid, and then boiling is opposite, going from a solid to a liquid. From a liquid to a gas. Okay? So if I look at freezing, I take a liquid, and I'm removing heat energy, and it's being converted from a solid to a liquid. Sorry, I reversed that. Freezing is when you remove energy from a liquid, and it's converted to a solid. If I add energy, let's say I add energy to a liquid, I heat it up. The molecules are going to move faster, and I'm going to boil it. So boiling really occurs when the molecules move faster. And when you look at water and it boils, you start seeing bubbles in there. Those bubbles are made up of gas, water in a gas state. There's actually not air in there. Okay, so this is Unit 1, Part 2. I'll have Part 3 next.